Looking at exercise 8F questions 8 onwards, they're a bit tricky because they don't tell you what formula to use. But the good news is once you set it up, it will indicate to you what formula to use, and for all of these you can use solve to work them out. In the lesson plan I noted that there was a mistake in question 8, so I'm going to write it out with the correction here. So the question says Sarah invested $3,500 at 6.75% per annum. The investment now amounts to, this is the mistake, so the correct value is $4,917.50. For how many years was it invested? Highlighting the correct information, what you should be able to transpose here from that question, it told us V0 was 3,500. It told us what little r was. Vn is the mistake, but that's what the future value is, $4,917.50. We're asking what is that n value? After how many years did it reach from 3,500 up to that number? Now, the indicator there, you can see the value has gone up, so we're talking about growth, not decay. So that's one of the questions you should ask yourself, is it growth or decay? And then ask yourself, what would be good to use here, recurrence relation or a rule? Now, it hasn't said anything about compound interest, so we also go straight to simple interest. For the purposes of most of these questions, using the rule and solve can be helpful. For this one, however, if you wanted to use the recurrence relation and put in 3,500 and enter, you can do it that way as well. But just to, in case the n value is really high and you don't want to go end to end lots of times, the rule is best. Just going to identify what the rule is that we're using. So in this case for us, D is equal to 6.75 divided by 100 times by 3,500. Which is $236.25. This is what we can pop in CAS using solve. The unknown value is n, that's the number that we're looking for. We've got D here, V0 here, and the Vn that we know what the future value is on the left. So we pop the n there, solve, and CAS gives us that beautiful one-step answer of n equals 6. Let's do another question. We'll do question 9. In the textbook it reads, how long would it take for $200 to exceed $20,000 if it was invested at 4.75% per annum compound interest? So again, we've gone up in value, so it's growth. It tells us compound interest, so we know to look there. And then we've just got to decide whether we use the rule or the recurrence relation. I'm going to go with the rule again, just in case the n value ends up being bigger, because it's asking how long will it take, so that's n. I'm going to go ahead and work out R for this one. because we're using the compound interest rule, the formula is Vn equals capital R to the power of n times by V0. In this case here for capital R, I've got 1 plus 4.75 over 100. So I get 1.0475, which I can now set up the rule. For Vn, it is the value into the future that I don't know how long, but I know that it is 20,000. So I can pop that on the left-hand side here. And then capital R, 1.0475. I don't know n, so I'm going to stick n in there, which is what I'm solving. And then V0 I knew was 200. Same as question 8, now I can solve. And I get n equals to 99.23, which you can round up to 100 years. That's a long time for an investment. So for all of these questions, what's required is this setup here. As you read the question, write down the information that it gives you with this notation. And then you'll usually have to work out what capital R or capital D is or something like that. And then again, the question will indicate to you by saying it's compound interest, or it might say it's reducing balance, whatever it is, and that will tell you what formula to gravitate towards. Generally, it's easier to use the rule to set that up to use solve, but you can do the recurrence relation if you prefer and if you think n is going to be a low number.